All right, welcome back everyone. In this video, as the title suggests, I'll be working some problems involving the complex numbers and complex roots, right, of both cubic and quadratic equations. Now, if you're just joining, I highly recommend that you check out my last two videos where I introduced the concept of the complex numbers and how to find the roots, well, the complex roots of quadratic equations. Now, in this session, we'll be working through these four questions that were carefully selected to cover a lot of ground in terms of what types of problems you may see on the exam. Now, it's important for you to have an understanding of the relationship between the roots and coefficients of both quadratic as well as cubic equations. I would have talked about the quadratic equations in my previous video, but the relationship with the cubic equations, that was discussed in the live sessions. So if you're serious about mastering Cape Math, I suggest you message me on WhatsApp. The number is in the description to join my live sessions. All right, so grab your notebook, your calculator. We're going to be diving straight into these problems. All right, so first question, we have to find the roots of the quadratic equation x squared minus 2x plus 5 equals 0. This is easy. I'm just going to go ahead and use a quadratic formula. All right, let's not waste any time. So we know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, minus b will be minus 2 because b is minus 2 times the square root of b squared, which is minus 2 all squared, minus 4 times a is 1 times c is 5 all over 2a, right? A is 1. So x will be equal to, this is going to be positive 2 plus or minus the square root of 4 minus 20. 4 minus 20 is minus 16 all over 2. So x is equal to 2 plus or minus, what is the square root of minus 16? The square root of minus 16 is going to be 4i. The square root of positive 16 is 4. The square root of negative 16 is 4i. Just remember that, right? So I can break this up. I have 2 over 2 plus or minus 4i over 2. This can cancel out to give me x is equal to 1 plus or minus 2i. So my roots are alpha, which would be 1 plus 2i, or, well, 1 minus 2i, whichever one, and beta will be 1 minus 2i, right? These are your two roots. So, next question. If one of the roots of the quadratic equation x squared plus px plus q is equal to 0 is 3 plus 4i, find p and q if all coefficients are real. Okay, now, what do we have here? We have a quadratic equation. How many roots does a quadratic equation have? It has 2 roots, right? That's because the order of a quadratic equation is 2. So, since one of the roots is a complex number, let's say alpha is 3 plus 4i, that's one of the roots. The other root, beta, will be what? Should be 3 minus 4i. Why? Complex roots always occur in conjugate pairs, right? Always remember that. All right, so moving forward with this question, the most efficient way to solve this would be to apply the relationship between the coefficients and the roots of quadratic equations. Just recall that the sum of the roots, alpha plus beta, is equal to negative b over a, and the product of the roots, alpha times beta, is equal to c over a, right? And the a, the b, and the c represents the coefficients of my generic quadratic equation. Now, alpha plus beta, alpha is 3 plus 4i, beta is 3 minus 4i. So let's just put that in. 3 plus 4i plus 3 minus 4i is equal to negative b over a. Now let's look at the coefficients up here. Our b, in this case, is going to be p. So we'll have negative p, right? Because it's negative b over a. And 4i and minus 4i cancel out, leaving me with 6 is equal to negative p. So p is therefore equal to negative 6, right? Now to consider the product of the roots, we have alpha times beta, which is 3 plus 4i times 3 minus 4i is equal to c over a. The c in this case is q. So I have q over the a, which is 1. So that's just q, right? And if you look at it there, this is the factorized version of the difference of 2 squares. So my result when I multiply should be 3 squared minus 4i all squared is equal to q, right? This is going to give us 9. This is going to give us positive 16, right? 9 plus 16 is equal to q.
So I'll have 25 is equal to q. So therefore, yeah, q is equal to 25. And that's it. We're done. Our quadratic equation will simply be x squared minus 6x, yeah, minus 6x plus 25 is equal to 0.
This one is slightly more difficult. So let x squared plus 2m minus 1x plus m squared plus 1 equals 0 be a quadratic equation where m is a real number. Find the values of m for which the roots are complex. Determine the roots for m is equal to 2. All right, so let's look at part A. To find the values of m for which the roots are complex. When will the roots of a quadratic equation be complex? There's a condition that we check for, and that will be the discriminant, right? When a discriminant is less than 0, we are working with complex roots. So I know the discriminant is b squared minus 4ac in our quadratic formula, everything under the square root. And the b in question in this case would be this entire 2m minus 1 as the coefficient of x, right? So I got 2m minus 1 all squared minus 4 times a is 1, right? Times c. The c is a constant. The c is this whole thing. That's a c, right? So m squared plus 1. And the condition was for this discriminant to be less than 0. So let's see. Let's solve this equation now, but inequality. So I expand. I have 4m squared minus 4m plus 1 minus 4m squared minus 4 is less than 0. All right, 4m squared and minus 4m squared cancel out. I have 1 and minus 4. That should give me minus 3. So I have minus 4m minus 3 is less than 0. All right, so let me carry over this minus 3. I have minus 4m. That's less than positive 3. And m is therefore less than. Once I carry over this here, I divide it. I will have to flip the sign. Remember, whenever you are multiplying or dividing by a negative, you flip the sign. So I have m is greater than 3 over 4. Well, minus 3 over 4. Right? Cast that minus there.
We have to determine the roots for m is equal to 2. All right, let's see about that. This is the equation up here. We just got to replace this m inside with 2. And then the quadratic equation we solve to find the roots. So we got x squared plus, it was 2m minus 1. So I have 2 by 2 minus 1. Let's put a square brackets here. That's the coefficient of x. Plus m squared plus 1. So I have 2 squared plus 1 is equal to 0. All right, that's very fine. All right, good. So I have x squared plus, this is 4 minus 1, so that's 3x, plus 4 plus 1 is 5 is equal to 0. Now we find the roots for this equation. So let's go ahead and use the quadratic formula. So I have x is equal to negative b, which in this case is negative 3, plus or minus the square root of b squared, which is going to be 3 squared, minus 4 times a, which is 1, times b, which is 5, c, sorry, which is 5, over 2a, which is 2 times 1. So x is equal to negative 3 plus or minus the square root of, this is going to be 9 minus 20 is supposed to leave us with negative 11. So I have, that's over 2. So x is equal to negative 3 plus or minus, well, I have the root of 11i, right? All over 2. Breaking this up, I'll have x is equal to negative 3 over 2 plus or minus root 11i over 2. So my roots are alpha might be negative 3 over 2 plus root 11 over 2i, and beta could be negative 3 plus 2 minus the root of 11 over 2i.
All right, so moving on to the next question. Given that f of x is equal to 2x cubed minus 5x squared plus px minus 5 has 1 minus 2i as a root, find the value of p given that p is real. I'm going to utilize the relationship between the coefficients and the roots of cubic equations. So, remember, for cubic equations, we started off with the sum of the roots, alpha plus beta plus gamma. We have a third root, right? So I have 3 roots, right? So gamma is our third root. So the sum of the roots will be minus b over a, right? Next, the sum of the pairwise products of the roots. What is that? That is going to be C over A. And finally, the product of the roots, alpha times beta times gamma, is going to be negative D over A. All right. Now, this is A, this is B, this is C, and this is D. Right? So, I have this one here first. Let's see what happens there. Alpha plus beta plus gamma. What is the alpha? The alpha is, let's say alpha is 1 minus 2i, right? That's one of our roots. 1 minus 2i. What is beta going to be? Well, remember what I said. Complex roots occur in conjugate pairs. So the other root will be 1 plus 2i. There's a third root. We don't know that. We got to find it, right? So plus gamma is equal to minus b over a, which is, well, in this case, the b is minus 5. So I have minus 5 all over a. A is 2, right? So simplifying, minus 2i and 2i gone. 1 plus 1 is 2. 2 plus gamma is equal to 5 over 2, right? Gamma is equal to 5 over 2 minus 2, right? Now, 5 over 2 is 2.5. 2.5 minus 2 leaves me with 0.5. So my answer is going to be a half, 0.5. Right? That's gamma. That's our third root. All right. So I got that. Now I need to find P, right? P is going to be C. So I'm going to utilize this equation. Since we have all of our roots, this is not going to be a problem. So alpha times beta, that's the first part. I got 1 minus 2i by 1 plus 2i plus beta times gamma. Beta is 1 plus 2i, right? Beta is 1 plus 2i. And gamma is a half. Plus alpha times gamma. Alpha is 1 minus 2i. And gamma is a half. That is equal to C over A. The C is P, right? That's equal to P over the A, which is 2. Good. Again, difference of two squares. This will give me a 1 squared minus 2i all squared, which is essentially 1 plus 4. P over 2. So P over 2 is 6. P over 2 is equal to 6, so P is therefore equal to 12. All right, now I said that this video would have had 4 problems, but I just got an idea for a 5th one, and you'll never believe this one. Find the cube root of 8. Wow. Easy, right? Cube root of 8 is simply what? Cube root of 8 is what? 2. Story done. Well, since you're at an advanced level, you should understand that the index of our root usually tells us how many answers we have. Now, the cube root of 8 should give me 3 answers. Just like how the square root of 4 gives me 2 answers, because here the index is 2, right? It gives me 2 answers. The 2 answers would be positive 2 as well as negative 2. So you're probably thinking, well, I'm missing 2 answers for the cube root of 8. And that's correct. So how do I find those 2 other answers? Well, this is how you do it. Now, you consider an equation like this. Let's say z cubed is equal to 8. Let's find for z now. Because, of course, finding for z would be essentially like if you're finding the cube root. Right? So I have z cubed. I'm going to carry over the 8. Minus 8 is equal to 0. Now, look at this. This is a difference of 2 cubes. Right? So I have z cubed minus 2 all cubed is equal to 0. How do I factorize the difference of 2 cubes? Remember, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Right? Remember that. So I have z cubed minus 2 cubed is equal to a minus b, which is going to be z. I'm just going to put this little thing in for the z so you don't mix up. Z minus 2 times z squared plus a times b, which is z times 2. So I have 2z plus b squared. The b is the 2, right? So I have 2 squared, which is 4. Now this is equal to 0. All right? Now I have a product that's equal to 0. So I have two scenarios here. Let me just write this out. Z minus 2 times z squared plus 2z plus 4 is equal to 0. I can have z minus 2 is equal to 0. And when I make z the subject, I have z is equal to 2, which is what we had up here. That's the easy solution. But what about the other two solutions? We gotta tackle this here. So we got z squared plus 2z plus 4 is equal to 0. Now this is a quadratic equation that we have to solve, right? So let's go ahead and use the quadratic formula. So z, now x this time, z is equal to negative b, which is negative 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times a times c, right? All over 2a. So z is equal to negative 2 plus or minus the square root. Well, this is 4 minus 16. So I have a minus 12 under there, all over 2. So z is equal to minus 2 plus or minus the square root of minus 12. Now, I can express minus 12 as the product of what? Let me see. 3 and 4 and minus 1. Right? And I can break this up. So I have, let me just bring the 4 in front. 4 times 3. I can break this up. So I'll have root 4 by root 3 by the root of minus 1. Now root 4 gives me 2, right? So I have 2 times the root of 3 times I, right? All over 2. Now, breaking this up, the bottom here, these 2's cancel out. So I essentially have z is minus 1 plus or minus the root of 3i, right? So, the cube roots of 8, the cube root of 8 is actually 2, as well as minus 1 plus the root of 3i, and minus 1 minus the root of 3i. So you see the other two solutions were, well, they had an imaginary component, right? They were complex in nature.